Hello everyone, welcome to another interesting session of the Astro Club. So today we're going to learn about a very interesting topic, that is rocket parts. In the previous session, we have already learned few things about rockets. Do you remember, all of you?
Yes, Akka.
Yeah, we learned few things about rockets. So today is a continuation of that session. We are going to learn about rocket parts. So if you see on the left side, this is the complete picture of a rocket. This is how the rocket looks like. Now on the right side, we have removed the outer skin. We have removed the outer skin of the rocket so that we can see the parts that make a rocket. If you see here, there are many parts that make up a rocket. And engineers group the parts which have the same function into systems. So there are four major systems of a rocket. So this is the inner structure of a rocket. If you remove the outer layer, inside the rocket, it looks like this. So this is the inner structure of the rocket, and you have different systems. For example, see here, you have the structural system, you have the propulsion system, you have the payload system, and you have the guidance system. And again, in the propulsion system, see, all of this comes under propulsion system. The fuel, the frame, the oxidizer, the pumps, the nozzle, and the fin. Okay, so you have different types of systems like this, and this is a rocket skeleton. Now let's learn about each and every system in detail. So now let's first move on to the structural system. So the structural system, or the frame, is similar to the fuselage of an aeroplane. So what is a fuselage? So the body of the aeroplane is called as a fuselage. So if you see here, see, this is the body of the aeroplane. This complete thing here, it is the body of the aeroplane. So this body of the airplane is called as fuselage. So the structural system, or the frame of a rocket. So in the rocket also, the structural system, it is similar to the fuselage of an aeroplane. The frame is made from very strong but lightweight materials like titanium or aluminium. So we can't make the frame with whatever material we like. We can make it only with like strong material, but it should be in lightweight, like titanium or aluminium. So this titanium and aluminium, they have uses in various type of industries, like telecommunication industry, automotive industry, motorcycles industry, in machinery, medical field, and in aerospace. So in all of these different type of industries, this titanium and aluminium are widely used. So next, the distribution of the structural weight affects the center of gravity of the rocket. So the entire structure has to be distributed uniformly. Only then the rocket is in a complete stability, and it affects the control of the rocket. Okay, the entire structural distribution should be uniform. Okay, during the flight of the rocket, then the stability of rocket should be maintained when the rocket is in flight. That is why the distribution of the structural weight is very important. So did you all understand up till here?
Yes, sir.
Yes, Akka.
Yeah. Now, during the flight of a rocket to the orbit, some parts of the structure are discarded. It is called the process of staging. Right, when the rocket goes up in the middle, these parts get separated.
Yes, Akka.
Yeah, so that process is called staging.
Light will be formed.
Yeah, so that process is called as staging. So like this, it gets discarded in the middle. Now, so there are different types of rockets which are designed by different space agencies. GSLV Mk3 is the heaviest rocket made by ISRO till date. So till date, so this GSLV Mk3 is the heaviest rocket made by ISRO. Because many other space agencies also make different type of rockets. Okay. Now, So that is about the structural system. Now we are going to move into the payload system. See, this is the payload system here at the top. So the payload is the rocket's carrying capacity. So when the rocket is going into the space, it should carry something, right? For example, in this picture, if you see, it is carrying the spacecraft. It carries the crew, the spacecraft, the satellites, the fireworks, the warheads. It can carry anything. The rocket can carry anything. So the rocket's carrying capacity is called as payload. The payload system of a rocket depends on a rocket's mission. So based upon what mission it is going to perform, the payload system of a rocket varies. Okay, are you able to understand?
Yes, Akka.
Yes, sir.
Yeah. So the earliest payloads on rockets were fireworks for celebrating holidays. In the early days, the rockets were mainly used to launch the fireworks only during the festivals and all. But now we are launching the satellites, the crew, different spacecrafts with the help of rockets. The payloads of the German V2 or the German war was like several thousand pounds of explosives. In the early days, like they used to send a lot of explosives in these rockets. Following World War II, many countries developed guided ballistic missions like missiles armed with nuclear warheads for payloads. But after World War II, what happened? Like many countries developed their missiles, and these missiles were launched with the help of rockets. And these missiles acted as the payload of the rocket. Okay. So the same rockets were modified to launch satellites with a wide range of missions. Now at present, what are we launching with the help of rockets? They're launching satellites. So these satellites have spacecrafts. So these satellites have a wide range of missions, communications, in weather monitoring, in spying, in planetary exploration, in observations. Okay, and special rockets were also developed to launch people into Earth orbit and onto the surface of Moon. So these are all the various uses of rockets, So see, I have already mentioned here the German V2 missile attack. Earlier, they used the rockets to launch the missiles. And these are all the different rockets of the world. You can see many rockets have been developed by different space agencies. So this is all. So that is about the payload system. Now, moving on to the guidance system. So the guidance system of a rocket may include very sophisticated sensors. So the guidance system here, see, this red colored part is there, right? Only that is the guidance system here. The small thing is the guidance system. So the guidance system consists of like sensors, onboard computers, radars, and communication equipment to maneuver the rocket in flight. Okay, so this guidance system consists of all those type of sensors and all of those. Many different methods have been developed to control rockets in flight. So when the rocket is in flight, like when the rocket is in space, we need to control it. So for those controls, we include sensors, computers, and different kind of radars in the rocket. So all of those things come under the guidance system because it is guiding the rocket. That is what we call as guidance system. The guidance system must also provide some level of stability. So stability should also be there for the guidance system so that the rocket does not tumble in flight. So when the rocket is going in the space, it should not tumble, right? It should not fall upside down. Nothing should happen like that. So in order to provide the stability for the rocket, the guidance system is very important. Did you all understand about guidance system?
Yes, sir.
Yes, sir.
Now
Yes.
moving on to the last type of system. So far we have discussed about structural system, payload system, and guidance system.
Guidance.
Now moving on to the last system, that is the propulsion system. Now let's see what a propulsion system is. It is a system, so the propulsion, mainly first we should understand the meaning of propulsion. Propulsion is any method that is used to accelerate a spacecraft and artificial satellites. So this spacecraft or artificial satellite should move from the surface of Earth into space. So that process of acceleration is called as a propulsion. The propulsion of a rocket includes all the parts which make up the rocket engine. So propulsion system means everything related to the engine, like the tank pumps, the propellants, the rocket nozzle,
Fuel.
yeah, fuel, all of those things. So rocket propulsion is a system which uses force to lift the rocket off the ground. So from the ground, if the rocket has to go into space, we should apply some force. Is it right? So all that force constitutes
Yes,
the propulsion system. When rockets leave the launch pad, initially they are settled in the launch pad, and when rockets leave the launch pad, they need a lot of power to lift them. The rocket simply can't go up like that. It needs a lot of power to lift. So accomplishing that feat isn't easy. We can't easily lift the rocket. So we need the propulsion system because it uses some force to lift the rocket. Because of the massive weight, rockets are very heavy, right? The rockets have to rely on a powerful propulsion system to move the rocket off the ground and into the atmosphere. So that is why we need the propulsion system. Is it clear?
Yes, Akka. Yes,
Right.
Akka.
Yes,
Yes.
Akka.
Yeah, so this is the complete information about the rockets. Like we in the previous session, we talked about introduction of rockets and the uses of rockets, the history of rockets. And in this session, we talked about the different parts of a rocket, like different systems, the structural system, the payload system, the propulsion system, and the guidance system. Okay. So,
Okay, Akka.
so now, now are you excited to do another hands-on project?
Yes,
Yes,
Akka.
Akka.
Yes, Akka.
Yeah. So now I'm sharing one video in our group. I shared the video. See, again, it is a rocket only, but not paper rocket. This is another kind of rocket. I think it's made of cardboard.
Cardboard rocket.
Yeah. Again, it is a rocket only, but it is a different type of rocket. So watch that video and try to make that rocket by the next session. Okay. In the same way, this time no need
Okay.
to send any video. I mean, like, because it's not possible, right? If possible, you can send a video like explaining it. Also, you can just send the picture of the rocket. Okay.
Okay, Akka. Okay, Akka.
Again, in the next session, we have to present it.
Okay.
Yeah. Okay.
Okay.
So, any more doubts you have?
No doubts, Akka.
No doubts. Okay. So I'll upload that today's event in the YouTube channel, and I will share the link. Okay. Yeah.
Okay, Akka.
Yeah. Okay. So that's all for today. Thank you for joining. You can leave.